All right, so who remembers how we do Kramer's rule? Yes. Find the determinant of the coefficients. We're actually going to find 3 determinants, but the first one we're going to find is just the coefficients. So these are my x's, these are my y's. Okay? Now when I evaluate a determinant, which I do in lots of different kinds of problems, like inverses, specifically I'm thinking of that, you have to remember that you multiply down, you multiply up, and then you subtract those numbers. So it's always downs minus ups. So my determinant is 7. This is a system of equations, just as though you were doing substitution or elimination. Your answer is going to be an ordered pair. X is 2, y is 6, something like that. The denominator of both of those is this number right here. So whatever these answers turn out to be, at least in the beginning, they're going to be over 7. 6 over 7, 2 over 7. That's going to be the answer. So now to get the numerators, we do 2 more determinants. Anybody remember how we do that? Cam?
You took like negative, if you're solving for x, you have to negative 7, 7,
In for the x column, yep. So these numbers right here now are going to come into play. And remember, this is the x column and this is the y column of numbers in the original determinant. So x, I'm going to do exactly what Cam said. I'm going to cut these out and paste them here. So for x, I'm going to have negative 7 and 7, and then negative 3 and 1. For y, these are going to get pasted on the y's. So I'm going to have 1 and 2, and negative 7 and 7. All right, Ellie, you remember that? Looking familiar? Okay, so now I evaluate these just like I did that one. So negative 7, negative 21, subtract, I get 14. 7, negative 14, subtract, I get 21. So the answer to the problem is 2, 3. Because I always want to reduce, simplify, before I write down my final answer. Okay, good, good, good. Who else?
Number 3 right below that column.
So same thing, we're on the back of page 1. Now we're doing number 3, which is find the inverse. So this problem starts exactly the way the last one did. We start by finding the determinant of our matrix. All right, so here we go one more time. That's going to be negative 4 and 30. I'm subtracting, so negative 34. So I'm going to hang on to that number. Does anybody remember what's the next step if I am finding the inverse? This is kind of a random thing where you do the switching around and all that, finding what we call the adjoint. So we take these 2 numbers and switch them, physically switch their places, and then these guys become opposite. So 6 becomes negative 6, 5 becomes negative 5. Then you know, anybody remember how we put these 2 pieces together? We take all of those and divide by negative 34. And then our final answer will be the simplified version of that. So that reduces negative 2/17. That one doesn't, but the negatives cancel. That one reduces 3/17 and 1/34. And that's the inverse. let's come up with some questions, because otherwise we're starting chapter 9. We don't have time to waste. We can't just sit around and look at each other.
You do the first by hand or back of page 2.
Back of page 2. It says solve using the inverse method. Okay, so we just found an inverse. So that's going to be the first step of this problem. Because if you're using the inverse method, you need to have the inverse. So to find the inverse, or excuse me, find the answer to the problem, remember that here's our coefficient matrix. That's the coefficients for on the back of page 2, the problem at the top. Those are the coefficients. So I'm going to find the inverse of that. So it's exactly what I just did. So I'll start with the determinant, which will be -1 and 6. So this one's -7. And then I make that adjoint matrix, so I'll do a little messing around here. These two change places. These two are changing places, and these are negatives. And then I'll take that adjoint matrix and divide everything in it by -7. So my inverse is 1/7, 2/7, 3/7, -1/7. Did I do that right? Would everybody agree that's the inverse? That's exactly what we just did, okay? Now the difference is, a minute ago, the question was find the inverse. Then, this one is solve the system using the inverse. Okay, so I'm not done. To get my answer though, I'm simply going to take this matrix, which is the inverse, and I'm going to multiply it by 8 and 3. If I multiply the inverse of the coefficients times the constants, I'll get my answer. Now, I know we went through this a little bit the other day. I just want to make sure you understand why this is working. You don't have to write this down. Just pay attention for a minute. This is my equation. I got my coefficients, my constants, or my variables, and my constants. There's my original equation. If I multiply both sides by the inverse, this will cancel, because inverses cancel, and it'll leave me with xy equal to the inverse times the constant. So this is going to give me my x and y. So if I'm using the inverse method, I multiply the inverse times the constants. Okay? Easy. This is a 2 by 2. This is a 2 by 1. I can multiply, and I'll be left with a 2 by 1, x and y. These are going to be my answers right here. So when I multiply first row, first column, I'm going to multiply 1/7, 2/7 times 8 and 3. So that's 8/7 plus 6/7, which is 14/7 or 2. So x is 2. Then I'll do the second row, first column. So 3/7 and -1/7 times 8 and 3 gives me 24/7 minus 3/7, which is 21/7 or 3. So the answer to the system is 2, 3. I'm with you 100%. If somebody handed me that problem and said solve it, I would not do it this way. But that's what the directions said.
Am I good to go?
Yep, you're all.
Is that all right with everybody? All right, anything? Look through that whole practice packet. You're supposed to have already done this. Monica.
Can we do number 2 on page 3?
Number 2 on page 3. All right, number 2 on page 3 is a graph finding all of asymptotes, intercepts, and holes. what is the first thing you want to do with these problems? Factor, yeah. You, in order to tell if you have holes, you have to be able to cancel. And you cannot cancel until you factor. So factoring kind of gets everything started. So number 2 on page 3 says x minus 3x plus 3 over x minus 4x plus 4. Nothing is going to cancel, which I don't know if that's bad news or good news. It just means we don't have any holes. So this problem will have no holes. However, it does have asymptotes and it does have intercepts. So where are the asymptotes going to be? We have vertical asymptotes at x equals 4 and x equals negative 4. Because vertical asymptotes happen where the denominator is 0. So your denominator is going to be 0 at 4 and negative 4. Perfect. Where's the horizontal asymptote? What?
Wait,
What?
is this not number 1?
We're doing number 2. So the horizontal asymptote is y equals 1 because you have x squared over x squared. So we got a horizontal asymptote at y equals 1. All right, do we have any intercepts? How do we find intercepts? Think of a T-chart. You're going to plug 0 in for x and you're going to plug 0 in for y, not at the same time, one at a time. Might be easier, it doesn't matter, but it might be easier to plug it into to plug 0 into the original. If you plug 0 into the original, won't we get 9/16? Which is the same thing you get if you plug it in here, you'll just have to multiply it out. So 0 9/16. And then how do I find my x-intercepts? I'll let y be 0, right? And you can think of that as 0 over 1. It doesn't matter. It's an easy equation to solve. That's going to disappear. The denominator is going to disappear. Because when you multiply it over to here, it's 0. So what are you left with? 0 equals x minus 3, x plus 3. Which means x has to be either 3 or negative 3. So as far as important stuff goes, that's it. Now we have to draw a picture. Do you have any thoughts? I think the middle part's pretty obvious. Got a little parabola shape going on here. Don't forget though, there's 2 more pieces to this graph. What do you think's going on the outsides? Aiden's going like this, I think he's right. Now again, I want to remind you, you've done enough of these, you know, I mean, you're anticipating that kind of shape, that hyperbolic type of shape. Remember that the only place you can cross the axis is where you've placed your dots. Those are the intercepts. So if you thought you might draw something over here, you'd be wrong because you can't cross the axis. So that's really your only alternative. But I'm taking a test, I want to get a good grade, I'm not sure, what can I do? Plot more points. put 5 into your equation, put 6 into your equation, and you will see that shape. You don't need to do that, but do it if you're concerned. All right, that's great. What else do we need to do? Anything on our homework, review sheet, notes?
We do, on page 7, 3J.
Page 7, J. That is notation for the transpose. And all you do to do a transpose is switch the rows and columns. So there are times where you need to transpose. For example, we did our 2x2 inverses by hand. And remember that new adjoint matrix we made? And we made it by flipping around some numbers and changing some signs on some others. When the matrix is bigger, you do that same process, but when you start flipping around numbers, you actually are flipping rows and columns. So the transpose is used in finding inverses. We're not finding inverses with it, but that's one of the applications of it. Whoops. So here's matrix C. So C transpose, which that can be a capital or lowercase, C transpose simply means the top row becomes the first column and the second row becomes the second column. So if C has dimensions 2 by 3, then C transpose will have dimensions 3 by 2. What was a row becomes a column. That's what it means to be a transpose.
Chicken sandwich. Can't go wrong with it. I never complain.
All right. What else?
Can we do A on page 2?
2A. Page 2A. Yep, partial fractions. So remember, well, do you remember, what's the first thing we have to do? Factor the denominator. Because when we are writing partial fractions, what that means is, what are the two little fractions that will add up to give you your big fraction? And the denominators of the two little fractions are the factors of the original denominator. So if you think about it, if you added these together, wouldn't that be your common denominator? Yeah, so that's what you're doing, you're kind of pulling it apart. So these need variable names. I'll call them A and B, we generally do, but you can call them P and Q or R and S, I don't know what you call them. So that's the setup. We factor the denominator of the problem. Oh wait, is this a lunch period?
Yeah.
Okay, all right, let's finish this up and then we'll break for lunch. All right, so now what? What do you think I want to do now? Multiply through by the whole denominator. Now, you are allowed to do this in your head if you do it carefully. I like to write it down. Okay. You can absolutely do this in your head if you're comfortable doing that. The idea is if you multiply every single thing by the denominator, you are going to lose all of your denominators. So in the original problem, you're just going to have 4x minus 5. Here, you're only going to lose this part because that's all you've got, but you're going to be left with ax minus a. And here, you're going to be left with bx minus 2b. The point is, get rid of the denominators. Now, that's an equation. balanced. So that means however many x's are in my left hand have to match the x's that are in my right hand. So 4 has to match A plus B. That's logic. The x's on this side have to be the same as the x's on that side. And similarly, the non-x's on the left have to match the non-x's on the right. So the purple things make an equation, and the green things make an equation. So now what do? Substitute or eliminate, or Kramer's rule, or inverse method, right? Whatever you want to do to solve this system of equations. I'm an eliminator, but that's set up perfectly for elimination. For everybody, I think that's probably the easiest thing to do. So we'll just add them together, and -1 equals -b, so it looks like b is 1. And if b is 1, then it looks like A, if I just plug back in, it looks like A has to be 3. Is that right? Now, this is the only time that we don't write our answers in ordered pair. Usually when we're doing a system of equations, our answer is in ordered pair. No, your answer is the fractions. So you're going to have 3 over x minus 2 plus 1 over x minus 1. A and B. This is the answer to the problem. Your job was to find the fractions. So that's what they are. Okay, does that make sense? All right, let's go ahead and break for lunch. If you want to do any